Input side phase loss 101. Good there. Good there. Holy gecko and ant town. What is going on? Let's trace some wires. 5.2, 5.4, and 5.2. Correct. Hey guys, got a trouble call today for a water system. It's kind of a spread out water system, multiple tanks and transfer pump sites. It's all fed from a single source though, a well pump. And over the last few days, the well pump faulted. The system's operator never received a message that the well pump had faulted and there's no water in the system. Okay, well, we look online, yep, we can see the tank's empty, and then, okay, we log in to their online SCADA, and yep, you had a well pump fault there a few days ago, and you even had a low water warning 2 days ago that your tank was below the start point for the well pump. Did you get those notifications? And the customer operator, I guess you'd call him, says, no, we didn't get those notifications. And like, okay, did you set up notifications? Anyway, long story short, it seems like the ball was maybe dropped at some point here in the last months, maybe, and they've kind of just been coasting on the system without really monitoring it or watching it closely. And so today it's kind of the perfect storm, worst case scenario for a private water system is there's no water, and that's the first sign they get. The whole idea of having a SCADA system is you get notified when you have a small problem before anyone else knows there's a problem, so that you have time to pivot and maneuver assets and resources and technicians to solve the problem before you run out of water, or before whatever your emergency is. But that is all dissolved, it seems like, and is not taking place. So part of today's trouble call will be kind of reassessing and rebuilding the communication between the owners and their operators, and then also we're going to be trying to trace down exactly what the fault is. Our SCADA shows well pump fault and soft starter fault. My plan is to just head right to the well site and see what's going on. Hopefully it's something minor and not something that requires a lot of downtime. Otherwise they're in for kind of a rude awakening if that's the case. Anyway, we'll head to the well site and we'll see if we can figure out what's going wrong and what we can do to fix it. Alright, see you there. Alright, here we are at the well site. Before I got here, apparently there's no power. But there's some kind of power. I don't know who said there's no power. Anywho, let's see what's going on. Main pump is in fault. Backup pump is off. Okay. Do we have lights in here? Doesn't look like it. Okay, so here is our well pump 1 starting can. And we are in a fault. Input side phase loss 101. Did we blow a fuse? Alright, let's see. So the fault on our soft starter for the well is input side phase loss, fault 101. Let's check voltage. Alright. 480 or 490, 490, 490. So it appears the power is good now. It's a little rich, but seems good. Let's check our system HMI. Yep, 200K tank is empty. Pump site 1 is calling for the well. But the well is not running because it's in fault. So I should be able to hit reset here. And it should take off because I'm seeing good voltage on all 3 lines going in. 1, 2, 3. So let's do it. Interesting. I'm hitting reset and it's not resetting. Good there. Good there. Good there. Just for kicks, we'll check the ground. Good. Maybe this type of reset you have to cycle power. Worth a shot. Let's try. Because we saw it has good voltage. Oh, okay. So it went to run, and then it showed input side phase loss 101. Interesting. So let's go to monitor. Those are all our settings. Our last peak current was 86. The heatsink temp is 95. Overload is at 0. And then trip settings. Overload trip. Remote start, trip fan, trip shutdown. Motor side phase loss on. Input side phase loss on. So I see that we have phases on this side. It is not a rotation trip. That would be line 1, line 3, line 2 trip. That's our rotation. What would be the risk in getting rid of it short term? Just to see what's going on. Honestly, we should meg the motor because there might be a problem down the hole. And when this thing is trying to ramp, if there's a dead short on the load side of this, it could be giving it this fault. So before I just completely ignore this fault, or disable it, let's meg the motor, and that'll rule that out. 480 volt, so we can do 1000 to ground. Put it on insulation test. Yeah, not great. Not terrible. 4.4. 4.4. 4.8, 5 megohm. Okay, well, maybe it's a problem in the soft starter. 0.65. 0.65. 0.65. All right, well, that makes me less nervous about sending power down the hole. And kind of curious about what'll happen. Let's see what the amps are doing when it first wakes up. Kind of curious about that.
run, or does it just shut off? Okay, well, it's not tripping this time. That's interesting. Okay, let's hit the start button. Why doesn't it want to start now? Very interesting. What is going on? Very strange. It's kind of making me think there's something wrong with the soft starter. There it is. Yeah, faulting on the input phase loss 101. Okay. Let's try turn that off. It sure is laggy on the inputs. And like maybe there's something wrong with the touch screen. Still trips on input side phase loss, even though we've got 500 on all three. And this touch screen is very, there we go. Did I need to hit like save or something? There, now it's off. Let's see if I remembered it when I go back. Yeah, it's off. Well, unless this touch screen is, man, it really is showing all kinds of weird. Yeah, okay, it's off now. Oh, see when I hit back, it kind of presses that one. What is that? Yeah, this is, I can't even navigate the menus. Okay. Good news is I do have a spare soft starter with me. That might work. Yeah, it just won't let me do anything but input side phase loss. While we're figuring that out, let's get well 2 running if that's possible. He's in off. That's good. So here's well 1 off, well 2. Booster is in auto, well 2 is in auto. Why is everything not working here? Holy gecko and ant town. Okay. Is the VFD dead? Oh, okay, yeah, we're good. VFD's got power. Well, this is in rough shape. And yeah, is this VFD any good? I guess that's another problem to look at, is why is the VFD not working? And then, do I go ahead and swap this guy out? Because he keeps showing input phase loss. And this touchscreen is very, very finicky. Not letting me do anything. And I think they have a button where you save settings or something. Save parameters. Yes. Okay, so now it's saved the parameters. That's the command I'm missing. So if I go into trip settings, input side phase loss is off now. So I saved the settings. We're back out here. Now we can cycle power. And it'll remember that I changed the settings. Otherwise, every time I cycled, it hasn't saved that little change. So we're going to try and send it and see what happens. All right, he's awake and not tripped. 3, 2, 1. Oh. Input side phase loss. It just won't let me disable that, will it? Input side phase loss is off. It's still tripping. What I want to do before I completely give up on this guy is look up his operations manual and just verify I know everything about that phase loss, input phase loss fault. And just make sure I've done everything I can to bypass that or satisfy that fault. And then if that's the case, he's coming out and I've got another soft starter in the truck we can throw in to take his place. So let's have a look at the manual. Trip code descriptions. 101, input side phase loss. 101 means line 1 is missing at the instant of startup. The line 1 phase is either missing or at a very low level. Check all incoming connections. If a main contactor is controlled by a digital output set to running, check that delay under settings is sufficient. Contactor delay under start settings. Let's try and change that. Start settings, contactor delay. Contactor delay is 160 milliseconds. Let's kick it up to 260. Why not? The effectiveness of this touchscreen is making this a little tricky. Save parameters. Yes. Okay, let's try it again. 3, 2, 1. Nothing. Input phase loss. 101 means it's losing line phase 1. At least it thinks it is. All 3 phases are good to ground and on. And on the soft starter, all 3 phases are good. Rats, man. Yeah, I think I need to just swap them out, honestly. It's going to be a pain. We got serial comms here temporarily. And then to figure out all that wiring. I do have a nice motor nameplate here, though, to set up the next one. So that's good. Okay, might as well get started. Okay, we got our control connections labeled and disconnected. Got a plan for how we're going to hook up our temporary starter. I don't really like how much energized parts there are in here. I guess it's just these lugs on top. These are all off, but I'm feeling paranoid today, so let's shut everything down. There shouldn't be any power in here. Yeah, none. Very good. Sweet. And we've got the fuses open, so we're just double, triple mint gum, super safe. We can close him. Let's get these off. We're brown, orange, yellow. And down here, we're just 1, 2, 3. We got no real choice because we're going through that motor saver. All right, let's pop him off and get this new one connected. All right, we got our WEG SSW07 soft starter all landed. And we just need to get our control terminals on him in the most basic sense. And should be good to go. Set up our parameters there. All right, let's get those control terminals figured out. 241 is our 120. Good. Okay, digital input 1 starts and stops the motor. We want 113B. Digital input 1. Good. And then 2 and 3 are both fault resets. Our reset is 134A. Okay. We have a common relay output, and then we have full voltage and run, it looks like, are our only 2 choices. Relay 1 and relay 2. The 2 we want is running and fault. Okay, yeah, that'll work. These are 110s. All we have to do is put one of them on the common. So here's 110 volts as a relay output. It's just wired a little differently than the other drive. And then so 137A is our running feedback. So this will have 110 on it when it's at full voltage. And then 135A will have voltage on it when there is no fault. There we go. That makes a little more sense. Always good to look at the wires with your eyeballs. Okay, I still have to configure that though. We're in off. To configure, enter programming mode, keep the reset key pressed during 5 seconds. Keep it pressed throughout the programming. When in programming mode, 2 LEDs turn on, overcurrent and fade loss, indicating the DI2 is programmed for reset. If 3 turn on, phase loss, overcurrent, and phase sequence is programmed for 3-wire command. If the overload turns on, then RL function is no fault. Otherwise, it is operation. To modify, change the overload dip switch and put it back in the previous position. The overload LED will indicate the new... Oh man, yeah, we're going to need a tiny little tweaker. The overload LED will indicate the new programmed function. Okay, got the happy blinking lights, that's good. Alright, let's change the setting. To enter programming mode, keep the reset button pressed during 5 seconds. Keep it also pressed throughout the programming. Oh man, do I really need like 2? I need a helper to do this? Okay, let's see here. Hold down the reset button. When in programming mode, 2 LEDs turn on. If the overload turns on, then RL1 is no fault. 2, 3, 4, 5. There we go. So 2 come on and overload does not come on. To modify, change the overload dip switch and put it back in the previous position. There it is. Overload LED on is no fault function. Okay. Phew. Boy, that is a very technical yoga position required to press this small button and flip that small dip switch. But we shall overcome. Got all them covered. There we go. So I don't know why it's not calling an automatic, but we got 52 amps. Is it showing run feedback on here? That's if I wired it correctly. Running. Great. Okay, cool. This soft starter will actually work. Yeah, 484, 490, 488. And your amps are 5.2, 5.4, and 5.2. Okay. So yeah, we just got to figure out the automatic. Why isn't it calling an automatic? Okay, so we got the well running. The backup pump drive is out. We'll look at that later. With the well running, the water meter is not showing any flow. So that's something else we can check. But I've got it in automatic, and it should be running with a call for well. Everything is saying call for well, except over here isn't saying call for well. I don't know why, and so I want to find out. This well pump 1 relay should be energized. It is fired from a wire called 120. What is going on? Let's trace some wires. So, after tugging on some wires here, because the labels are a little misleading, our call for water source passes through this call for pump relay here, which is not energized. And it is 20, which is up here, which is Y0. So we need to find out why Y0 is not energized on this PLC. We'll connect with our laptop. But just to show you, when call for pump goes, boom, there's well pump 1. But I have this little tab lifted for now, so we can play around and it won't interrupt anything. As far as the soft starter is concerned, the controls are calling for it. Okay, we're connected to our PLC through our Ethernet network. Let's see here. We are looking for Y0. Okay, and let's turn on status. So Y0 gets set when this is true, that is true, and T1 is true. X2 needs to be true in order for T1 to accumulate. What is X2? It's probably something obvious. X2 02. Okay, yeah, so it's not running because it's getting a run feedback. That makes sense. Let's disable the run feedback. Boom. Okay, so now in the eyes of the SCADA, the well is no longer running. This timer is going to accumulate. That's our cycle stop timer. When that gets to about 10 minutes, T1 should elapse. And then this is probably our remote call. T1 should elapse, this will close, and Y0 will get set. Call for pump will go true, and well pump 1 will go true, at which point I can flip this down and put this relay back in, and it'll see a run feedback. Why isn't any flow being registered, or a flow fault? Unfortunately, these old DLOs, nothing is labeled. So we're just going to have to troubleshoot the water meter for now. Otherwise, I'm going to be really wasting a lot of time trying to get in and out of this. Okay, we're 1/9 of the way there. Very good. All right, we'll check back in as we get closer, and then hopefully we can have it running in automatic. Because if we go to pump site 1, they are calling for the well, so it should work. Okay, so we currently have the well relay, start relay, WP1, flipped up. I don't know if you can see that. But we also have the well cycle stop timer about to reach 9,999. When it does, T1, this will close and Y0 will activate, which closes our call for pump relay, which should light up this actual relay. As soon as that does, I'm going to slip this guy in, and that'll be our run feedback. Here we go. 3, 2, 1. Good. Close that. And there's our run feedback. Perfect. So now it's calling for well pump 1 in automatic, calling for well pump, and it sees the pump running on our run feedback right there. Perfect. So now we're in automatic. So if the SCADA system stops calling for it, it will shut down. Now, as much as they need every drop of water, I want to get that water meter fixed. So we're going to look at doing that. Okay, I just shut down the well pump. You can see our cycle stop timer climbing back up. It'll go back into call and await me to put it back into automatic. So we've got him off. I can open that disconnect out there. And I can open this one too, honestly. Yeah, let's just open that one out there and see what happens. And then I can work on this water meter. So just like checking voltage in an electrical circuit, before you work on it, you always want to check pressure in a hydraulic circuit before you work on it. So we're going to be working right here, so I want to just open that up to vent to atmosphere. So there's no chance of this thing blowing off in my face. I have a sneaking suspicion that there's just some rust in here, keeping the mechanism from spinning. So it's worth an attempt. So before I take them all the way off, I like to just break the seal, just out of another level of paranoia. I do have it vented there, but just in case there's pressure in there, I want it to get caught on these bolts. But now that I can see there's no pressure, I can safely get these bolts all the way out, and I don't have to worry about this thing going kaboom and flying. Okay, there's definitely some schmutz in there. And yeah, there was some schmutz. Because now it's spinning great. There must have just been a little rock wedged in it. So yeah, you can see inside there is a small paddle wheel. And there was just a small little stone in there, or a piece of rust that was keeping it from spinning. And now it's all good, so we just put our O-ring back and then just set them back into the meter body, and we're good to go. Close that. Get the arrow correct. Oh, well, that's an improvement. The total's going up. We still have a fault active, and because of Windows 11 I can't connect, but I'll take that. What do we got? It should roll over to flow here in a second. There's a T450, that's the size of the meter. 77 gallons a minute, that sounds about right. Cool. Alright, I would call this a success, all things considered. We got here, the soft starter was showing loss of line input phase 1, again and again and again, even with that fault disabled, which was weird, and with good phase voltage on line 1. So that didn't make any sense. We megged the motor, it megged out good, and then after just checking the manual for what could cause that loss of phase on 1 fault, we went ahead and changed out the soft starter. So now they've got a temporary soft starter in there. It appears to be working. It's giving run feedback. It's not throwing a fault. It should throw a fault if one occurs. We'd at least see that on our SCADA. It's running in automatic now. We had an issue where the cycle stop timer from the radio communications wasn't quite linked up with the site communications or site computer. But now that's all working good. Cycle stop's working good. And then we also saw the flow meter wasn't reading any gallons per minute or any flow. We opened that up and found there's a little piece of rock or rust in there and got that wheel to spin freely again. So now we're seeing flow. So that's good. They have a backup pump. They have a backup well pump down a hole that's really small. And then they have a booster pump that runs on a VFD so that they can match the flow of the booster pump that sends it up the hill with the well pump that sends it from below. It's a real temporary system, only for emergencies, but the drive has voltage applied to it and is probably all full of the same amps and stuff that got into this panel. So I'm going to get them a quote for a new VFD for the backup pump, a quote for a replacement Stellar soft starter, and then we need to have a serious conversation about, do they want to take on doing regular system services? Who's going to get the call out notifications when things go wrong? Do they want us to monitor it? If they do, we can work up a proposal for that. Otherwise, we're just here to essentially help them monitor their system, but it's in their hands to make sure everything's operating correctly. So it's up to them, really, where to go from here. But otherwise, I'd say this is a success. They had no water, and they were on the verge of not having water for a while with no backup pump. But fortunately, their single well pump is operational. Hopefully, this is a good wake-up call for them to just invest a little bit more in maintenance and servicing their system. Other than that, pretty good. All right, guys. See you on the next one.